Hello everyone, welcome back to my YouTube channel. So in day 6 of Kubernetes series, today we are going to understand the services. Are very important concept or objects in Kubernetes cluster. So let's understand in more detail. So what is a Kubernetes services? So a services in Kubernetes act like a stable front door for your app. So by default, when we deploy our application inside a Kubernetes clusters, we cannot directly access it. To access our application from outside the Kubernetes clusters, we need a services. So basically, services provide you a fixed IP and DNS name for your applications. And generally, the use of services is to route the traffic, and services use labels to find which pod to send traffic to. So any pod with the matching labels become part of the services. So here that's what we have discussed in previous video, labels and selectors. So generally we use a labels and selectors when we have to reference something. So like when we deploy our applications, we will create a service manifest file, and there basically we will reference our pod details. So services will know, okay, I need to send or I need to route the traffic to this particular pod. So in short and simple, generally services used to expose our application outside the Kubernetes cluster. Okay, let's move to next slide. So there are different type of services available in Kubernetes. So the very first and default is ClusterIP. If you will not create any services manifest file, then by default itself, when you do a default pod deployment, then also you will get a cluster IP address, because this is the basic or default service for Kubernetes. So the purpose of cluster IP service to expose the services on a cluster internal IP address, so the pod can communicate with each other. Accessibility, only reachable from within the Kubernetes clusters. So if we are using service type as a cluster IP, in that case we cannot access our application outside the Kubernetes clusters. This is ideal for internal microservices communications, like for front end needs to talk to a backend or database. In that case we can use cluster IP services. And so basically it is beneficial as well, because we are not exposing our databases. But for front end we cannot use cluster IP, because the external users are going to access our front end part. Another service type here we have is NodePort. So the purpose of NodePort service is like basically provide it allow outside access from the Kubernetes cluster. So what does it mean basically? So we can expose the service on a static port on every node in the clusters. So basically we will map a node port to the our application port basically. So we will see in a demonstration, then it will be more clear. Just for understandings, like suppose this is my local system, and on my local system I am running my Kubernetes cluster as part of Docker desktop. In that case my local system will act as a node, so I can access the application which we will deploy inside a Kubernetes clusters from our local system, because the local system treat as a node, worker node basically. So the service basically will be open in one of the port on our local system, and we can access our application. How it works basically NodePort. So as I already told you, so let me give a quick overview from here as well. So it basically automatically create a cluster IP service underneath Kubernetes, then open a specific port, the node port, typically in the range. So when there is one important part here. So if you are going to use a node port service, in that case you should always choose a range between 30,000 to 32,767 on every single node in your cluster. Otherwise you will not be able to access your application from your worker node as well. Any traffic hitting that node port on any node is then forwarded to a service cluster IP and subsequently load balanced to the backend port. So if you see the hierarchy, still they are using in a background cluster IP for communications, but they are allowing our node machine, our worker nodes to basically, we are mapping here our worker node IP and port with our application pod IP and port. So that's how basically we are going to stabilize a connection. Use case, so this is very quick and dirty external access for development or testing as well. So ideally we generally don't use NodePort services in real words. Generally we use another third one which we are going to discuss, which is load balancing service. Okay, so the load balancer service, basically the purpose of load balancer service is to externally access our applications without any port mapping. Like we are not going to map here our node port, basically worker node port. So we are not basically allowing traffic to a worker node port here. So if we use a load balancer basically, so generally we use, if we are using any cloud hosted like Azure, AWS or Google, then we use their load balancer to access our application externally. If we are using on-premise environment, then we have to set up our own load balancers and then we need to redirect the traffic. So the accessibility part here, accessible from outside the cluster via dedicated externally accessible IP address provisioned by your cloud provider. So like from the public IP address basically. How it works? So it automatically create a node port service and a cluster IP service. So in background, the load balancer service is also going to use node port and cluster IP service. And in NodePort service, when we discuss the NodePort service, we're only using cluster IP service. So when we deploy it in a cloud environment like AWS, GCP or Azure, Kubernetes interact with the cloud provider's API to provision an external network load balancers. And this external load balancer is configured to route the traffic to the node port opened on your Kubernetes node, which then forward it to your pod. So first, whenever we suppose we have access or we have enabled a public access for our applications. So whenever the user hit initially, the request first will go to a load balancers. From the load balancer, it will route to a particular Kubernetes cluster node port. Then from the node port, it will go to our application port. So this is the preferred way to expose public facing application in a cloud environment. It provides a single stable public IP address and handleless load balancing as well. Limitations, so it only work with cloud providers that support it, incur cost for the external load balancer. So if we are using a load balancer service, then definitely we need to pay extra charges because we are going to consume their services. Okay, so another service type here we have headless service. So this is very rarely we use, so that's why I have mentioned here a special case. So it provides a service discovery but without a stable cluster IP or load balancing by kube proxy. How it works? So you achieve this by setting up a cluster IP. So basically when we have to use a headless service, in the configuration we have to specify cluster IP is equal to none in the service specifications. Instead of single IP, the Kubernetes DNS servers directly return the IP address of all the pods backing the services. So use case also we will see here. So when you need to interact directly with individual pod, not through the load balancers. Example, stateful sets for databases where clients needs to connect to the specific replicas. In that case, we can use headless services. So for headless services demonstration, also we will see when we see a demonstration or when we will discuss stateful sets application part. Okay, So there are basically, we have discussed only 4 services. There are one more service which is external name. So generally we don't use this service, but the primary services are ClusterIP, NodePort, load balancers, and then we have one more Nginx as well, which is most popular. So I will create a separate video on Nginx part, because that is not basically that is not fit at this level. Okay, so this is the whole comparison I have specified here. If you want, you can pause the video and go through this particular table. So now let me go directly to a demonstration part. Okay, let me open my GitHub repo. So here we have K8 fundamentals, and we are on day 6. So let me go to day 6. So here we are going to create basically 4 manifest files. So one is for deployment, another for ClusterIP, load balancers, and NodePort. Okay, so let me open my Visual Studio Code as well. So let's first quickly create Nginx deployment.ml file. So what we will do, let me open this, and let me copy the file name, which is nginx-deployment.ml file. Now let me open my Visual Studio Code here, and I will simply copy the content. So if I if I'll explain this file basically, so if you see, this is the same file which we have used in previous demonstration as well. So that's why I have not write it down manually to save some time. So here you can see we have a basic deployment manifest file which we have discussed in deployment videos. Now the liveness and readiness probe also have included here. So this is also we have covered in previous video. So if you want to know more about liveness and readiness probes, you can go and watch out a previous video. There is a dedicated video on liveness and readiness probes. So what I'm going to do here, I'm going to deploy 3 replicas of Nginx application as part of this deployment manifest file. Okay, now let me save this file. So before that, let's see if by default we are getting any services or not, because when we create a Kubernetes clusters, by default we will get a ClusterIP service. So to verify it, let's verify kubectl get and svc. This is a short form of services. So here you can see we are getting default ClusterIP services. We have not created any services so far, but still we are getting a ClusterIP services. So that this is why Kubernetes created this service by default, for internal communication between your pods. Like inside the Kubernetes clusters, resources can communicate with the help of this service. Okay, now let me run kubectl apply -f and file name. So we will deploy our deployment.ml file. Let me clear the screen. Kubectl get pods. So here we will have 3 application pod or identical pods up and running, but still you can see the status 0 out of 1 because it is still starting in background. So if I rerun it, so you can see the status now 1 out of 1. It means 1 pod is running. Now let me clear the screen. Now what we will do next, we will create a ClusterIP services, custom ClusterIP services. So for that, let me go to my GitHub repo, and let me open this file. I will create a new file here and will paste the content. So here again API version is v1, kind is service. This is the name of our service which we are going to create. Specification, you can see selectors here. So app colon nginx demo. This is the label which we have defined in our deployment manifest file. So if I'll go back here under specification, sorry, not here. Okay, so under templates, this is the template for our application of pod basically. So here you can see the labels. We have app colon Nginx demo, and this deployment is also going to use the same label, which is app colon Nginx hyphen demo. So our applications or the services will know, okay, I need to route the traffic to this particular application pod. That's how basically we references. So this is the main use case of labels and selectors as well. Okay, so let me close this file and let me save it. Now what I will do, I will run kubectl get, sorry, not get, apply hyphen f and our services, which is nginx services hyphen clusterip.ml. Okay, so let's verify kubectl get. So now you can see we are getting two services. This is the default one and this is the one which we have created. Now what we will do, we will try to access our application from this service basically, but directly we cannot access because we have not exposed this service, as we cannot, because this is the internal or default cluster IP services. So there is a one options if you want to still use a cluster IP for some kind of testing or demonstration purpose. In that case, what you can do, you can use a port forwarding command. With the help of port forwarding, you can still access our applications. So for that, let me type a command kubectl port forward, sorry, forward, and here we will use services and the service name. So service name is Nginx cluster IP service, and here we have to give a local port on which port you want to access this service. So for example, I will give 9099 and colon we have to give a service port. So service port we have here is 80. So let me provide here is 80. Okay, so it is forwarded traffic to this particular port. So if I'll go back to my browser here, and here if I'll search localhost colon, sorry, not 9099, so we are able to see a home page of our Nginx application which we have deployed. So there is a way to use a cluster IP and we can access our application with the help of port forwarding, but as soon as we will close this connection, we cannot access. So if I cancel it now, if I go back and refresh it, we will not be able to access our applications. Okay, so so that's how basically we use a cluster IP services. Now let's use a NodePort services. So let me go to my GitHub and we'll create another service file which is not LoadBalancer. First we will see a NodePort services. So let me copy the name here. I will create a new file here and let me copy the content. So here again you will see we have most of the things common, but there are two difference. You can see NodePort and type. If I'll go back to my services, so we have under ports we had protocols, port, target port and type. So here type was cluster IP. Now in here type will be NodePort and the NodePort we have to add. So here you have to specify a range between 30,000 to 32,767. Then only you can access the application. So we have assigned here port 30,080. So now let me save it and apply this manifest file. kubectl apply -f and file name which is nginx nodeport.ml. Okay, so if I'll clear the screen, if I'll search for kubectl get sbc, so now we have created another service type which is NodePort service. Now we can, you can see it is already forwarded a port as well on 30,080. So let me copy this port. If I go to my browser and if I change this port, Now we can access our application. So that's how we can use a NodePort services to access our applications. So the benefit here is, if like there is no process is running, so once we have forward the traffic with the help of NodePort, we can access our application. So as soon as like till we have this service up and running, we can access our applications. But in the case of ClusterIP, as soon as we disconnect the session, we cannot access our applications. Okay, so now let's see load balancer service. So let me close this one. Okay, so let me copy the name first. This is the file name, and we'll create another file, and let's copy the content as well. So again, still till here we have a same file which we had in ClusterIP. The type is only changed. So like there is not this is very simple to use a services in your real world as well, because most of the services have a same kind of aspects apart from a type. So type is going to change, and in NodePort we are going to add another type which is NodePort to to enable a particular port. If we will not enable, then by default it will pick any random port. Okay, now let me save it. So here ideally we should be able to access our application on port 80. Let's verify. First we will we will apply kubectl apply -have and file name. Okay. So now we will have 4 services: kubectl get svc. So now we have another service type which is load balancers. And we can see in load balancer also it is forwarded a traffic to 315674 ports. Let's verify first port 80. So I will remove. Okay, let me open another browser, localhost. So you can see on port 80 we can access our applications. Why we are seeing here a port here, port 80 colon, sorry, not here 80 colon 31564, because as we discussed in a presentation in PPT, basically the load balancer service in background, it will first route the traffic to a NodePort service. From NodePort service it will route the traffic to our application pod. So that's why for their backend reference, it is basically enabled this it's allowed the port 80 on local system or outside the world, and in the background it's choosing automatically a custom port where it forward the traffic. So this is for internal communication, but we should also aware why we are getting this output. So now we are able to access our application with load balancers. If I'll go to NodePort, so from NodePort also we can access, and if we will use a port forward, then we can also access our application using a ClusterIP as well. So I hope it's clear. In case if you have any doubts, you can ping me over comments. So that's all for today. See you in next video. Thank you so much.